Hi friends of tracking, welcome to this last video on valuing actions in football. In this tutorial I will explain to you how we can analyze the models that you trained in the previous tutorials and how you can analyze results that get out of the models. So let's get to the notebook. In this tutorial I will demonstrate how we can analyze the trained machine learning models that were trained in the previous tutorial and also how we can use those models to value on-the-ball actions in football. If you haven't watched the previous tutorials, I would advise you to first do those before you watch this video. So let's get started. We first import all necessary libraries before we continue. Then we will need the data. So we will first import the games dataset. So now that we've loaded the day of games, so the dataset with all the games in there, we will split it up into a train and a test set. So we will train the models on the training set, the all data in the training set, and then we'll analyze the results on the test set. In this notebook, I will show you how we can do this for the Spanish La Liga season. So all matches that were not played in this season, this competition, will be used in the training set to train the models, and the La Liga season will be in the test set. So as you can see, this is like 10 of the matches that are now in the training set. And we will also create a test set. Then we will load the features that you already generated in previous notebooks. This might take a while to load all features for every game. So now we've loaded all features for all the games in our complete dataset, so both the train and the test set. And these look like these. So we have a lot of features on every action preceding a game state. And if you want to learn more about these features, you can watch the second tutorial where we explain how we get to this data set. And if you have generated your own features in this tutorial, you can of course use it in this tutorial as well. Well, we also need the labels to be able to train the model. The labels include the label for the good goal, also like the scores one and the concedes one. So the scores one counts or calculates whether there's like a goal being scored within 10 actions, and the concedes is the other way around, whether a goal was conceded within 10 actions. So these look as follows. In one of the games in our data set, there was a goal near the end of the match. And now we will create the train and test sets with their so with the features and with the labels, and we will select only the games in the training set for the training set of course, and only the games in the test set for the test set. And these are all columns that are now in our X, so our features data frame. So here we select a number of features. You can try it out yourself, so you can add other features. And if you want to learn more about this, you can watch the third tutorial where we dive a bit deeper in how you can create your own model. So if you've done that, then you of course can use it also in this tutorial to analyze the results of your own model. Here I selected a number of features that I think are important to value game states. And we also tell notebook what the labels are. The next cell will take a while, because in this cell we will train two models, one for the scores label and one for the concedes label, because we need both models to value actions. In the third tutorial again you can learn more about how to tune your hyperparameters and how to do this. So let's do this. So now we've trained the two models that we need, so the scores model and the concedes model. And in the next cell we're going to analyze the importance of the features in these models. So let's do this. So what these two figures show is the importance of the features in the two models. So the first one is our scores model to predict and to estimate the probability that within 10 actions there will be a goal scored by your team. And the bottom one is the one that you estimate the probability that you will see the goal within the next 10 actions. And you learned more about these models in the previous tutorials, of course. So here we can see the most important features for these models. If you look at the upper one, the most important features are on the top, and on the x-axis you see the f-score. So the higher the f-score, the more important the feature is in your trees. So here we see that the end distance to the goal of the current action, so the current action of the ends in the game state. If we want to analyze what is the most important feature, that's kind of logical, because the closer to the goal, the chance of scoring will be higher, of course. And we see a lot of features that are very important that are related to the location of the ball, of the current situation, and also of previous situations. And we see a similar trend in the conceits model, where also the location features are very important. And also interesting to see is that the team features, so that's the ones that indicate whether the previous action, so the team -1, indicates whether the previous action was executed by the same team as the current action or by the opponent. And we also see those features popping up, but they don't have a very high feature importance. Another way to look at feature importances and how they, how your model looks like, so how it gets to its predictions, is look at SHAP values. And if you want to learn more about SHAP values, I would recommend you to look at this, look at the page of SHAP. And here we will analyze the SHAP values of our scores model. And if you want to, you can also look into the SHAP values of the conceits model. And of course, you can plug in your own models that you trained in the previous tutorial and see how they work. So here you see the SHAP summary plot, and in this plot you see the most important features of our scores model, and you see how they impact the predictions for certain observations. So all the dots in this plot are observations in our test set, and when the dot is red, it means that it's a high value in this observation, and blue is a low value, and the impact on the prediction is positive if it's like on the right hand side of the 0, and negative if it's on the other side. So when we look at the team -2 feature, this one indicates it's true when the 2 actions ago that action was executed by the same team as the current action, and it's false otherwise if it's like executed by the opponent team. And we see that if it's the case that the 2 actions ago the ball was in possession of the same team as now, then in general the prediction will be higher. So this feature has like a positive impact on the prediction. And in this way you can analyze your model, and you can understand what it's learning. You can play around with adding more features, and you can see what the impact is of those features. So I think it's very important to understand what your model is learning and how it gets to its predictions. So another interesting thing from SHAP, you can also, it's also in this GitHub page, but you can also investigate single predictions to see how, to give its value for a single game state was, how the model got to its prediction for that. Check that out if you're interested in that. So now we will use the 2 trained models to predict. So we will first predict the game state values, both the conceits and the scores value for all the actions in our test set. So our DFX test, and we use the features that we selected before. And we can have a look at the predictions, and now these are the 10 predictions for the last 10 actions in the test set. And we see the values that it estimates for scores, probability, and concedes 1. In the next cells, we will use these predictions to value the actions. And first, for that, we will need to import all actions, and we will also import the players and teams such that we can later analyze the ratings per player for a particular team. So now we're getting all this data, and then afterwards we will merge this action data frame with our predictions. And then in this cell we will use these predictions to value the actions. So the action value, the vape value, how we call it, uses these predictions to value actions. And it was already explained in other tutorials, but what it does, it measures the increase in the scores value, gadget value, and the decrease in the conceits value, and then the sum of those two will give you the vape rating for a single action. And that's what we're going to do here. This value is the function from the circuit action library that we imported in this notebook. We got all values, and then we can have a look at this data frame. What it shows is for every action in our data set, we know the player executing the action, his birth date, the team that they belong to, they played for in this match. Then we here have the scores and concedes predictions, and those are used to calculate the offensive and defensive value of a single action, and together those make the vape value. So, if you're interested in getting better understanding, you can of course analyze these and look at the vape values for particular actions that you're interested in. What we're going to do now in this notebook is we will use these ratings to rate players. Because in the end, that's a very interesting thing that we can do with these ratings. So let's first group by players. So we will group by player, and then for every player in the data set, we will count how many actions he did in this La Liga season, the average vape value for his actions, and also the sum of all vape values. So if we do this, we see the following 10 players with the highest sum of the vape ratings. And maybe no surprise that Messi is on top here. But good to imagine, to realize here is that this is not really a fair comparison, because not every player plays the same amount of minutes. So therefore we will have to normalize for the minutes played. Like you see for every player in this season, because you need to have the same amount of time to get to the ratings. So to add these minutes played, we will have to read in the player games data frame that we already created in the first tutorial. And here we can now group by a player ID again, and we will sum the minutes played in this season for this player. So we look as follows. So for every player ID, we will have the minutes played in this season, and then we will merge this with the ranking that we already had over here, and then we will not execute this one for now. We will do this later in the tutorial, but we will calculate the vape rating for 90 minutes and also the actions for 90 minutes. So the vape rating for a particular player is the sum of all his actions, so of all the ratings for every action, And then we will normalize per minutes played. So we can say like, okay, for per 90 minutes, he brings this value to his team. And a similar way, we can also calculate the number of actions that a player executes in this per match in the season. Do this, and then here we will look at the threshold for minutes played, because we only want to consider players played a reasonable amount of minutes to make a fair comparison. I set it to 450 here, but well, you can play around with it. So we only select players with at least more than 450 minutes in the season. And then we can sort the values on the vape rating. Ascending is false, so the highest vape rating will be on the top. And well, still it's Lionel Messi 0.87 in the season. And it's way higher than actually number 2 Sanabria. And also, well, Gary Bill, Ross was popping up in this list. And of course, if you train your model in a different way, you can get different names in this list. So you can also play around with it and see what the influence is of training a different model and using different features. So now we know who was the player with the highest vape rating in this season. Then we can also see how did Messi get to this vape rating. So what actually the vape rating is it's like it's actually like the number of actions that a player does on average per match. So 71 in the case of Messi times the average value per action, and that gives you the vape rating. So therefore we can also look at the quantity-to-quality trade-off. So you can do more actions with lower value, or you can do less actions with a higher value, and you can get like a similar vape rating. And for example, we see in this list that Sanabria has a way higher average vape rating, but has way less actions in a match on average. So in this cell we will plot it in the figure. So here we've got the average vape rating per action per player and the total number of actions per 90 minutes. So every dot is a player in the data set, and I colored red the 5 players with the highest rating and highest vape rating in the data set. And well, as we already saw in the list, Sanabria has a very high average vape rating, but he doesn't do a lot of actions in a match. On the other hand, Messi is more balanced, so he still has a very high average vape rating, but he also executes a lot of actions on average in 90 minutes. And you can also play around with this, and you can investigate certain points in this figure to get an understanding of how a certain player behaves and how he gets to his vape rating per 90 minutes. Another interesting trade-off to investigate is the risk-reward trade-off. So, play an action this is unsuccessful will likely have like a negative rating, and we can see what average rating a player gets for a successful action, so average per 90 minutes. And we can also look at the average rating for the unsuccessful actions per 90 minutes. And if we do that, we can see what kind of players take more risk or less risk, and how they get to the values. So for example here, we calculated per player the sum of the successful actions and the failed actions, and also again we normalize for the minutes played. And if we look at the players over here with the highest, actually the lowest, so the most negative fail ratings, we see that Fernando Torres and Lionel Messi were the ones with most negative contribution in terms of the unsuccessful actions. But you see that Messi compensates this with his successful actions, still making the most valuable player in this season. And again, we can also plot this. And here you can see these ratings. So on the dotted line is a similar as in the the upper one. So here the dotted line, every player on this dotted line has like would have like a similar rating as Lionel Messi. This is like the multiplication of the number of actions per 100 minutes and the vape rate, the average vape rating. And also in this plot, in the risk reward, we plot it with dotted line, and this is the sum of those two axes. So on the x-axis you see the rating for the unsuccessful actions, and here for the successful actions. So the more to the left, the higher risk the player takes, and the more up, the more value he brings with the successful actions. And we clearly see Messi here also taking some risk, but also compensating with the actions that are successful. And for example, Bardi is a player who loses the ball less often, or like has less negative contribution with his unsuccessful actions, but he doesn't compensate that much as Messi does with his successful actions. So again, also here you can investigate other dots in the plot. And then the final thing that we will look at in this tutorial is the rating per action type. So of course, for every action we know the rating, and to also know the action type. So we can also analyze what type of actions a certain player got his ratings. So for example, over here we look at the rating for interceptions. So normalized per minutes played. We see, for example, Sergio Busquets with a high rating for interceptions. But we can also take a look at the cons, for example. There we see other players popping up: Fernando Torres, Lionel Messi, Guedes, and for example, we can look at shots, and there we see Sanabria, Messi, Suarez, mostly attackers, of course, that have high contribution with their shots. And again, also here you can play around, you can have a look. You can also look at individual players and see how they got to their total contribution, and see what their strengths and weaknesses are. So that was this tutorial. So we looked at the trained models and how we can look at how we can better understand what the model is learning, what features are most important. And then we use those models to rate actions and to analyze the player ratings in different aspects. So the best player in terms of vape rating in the season, what type of actions they get this rating, with the risk-reward trade-off, and also the quantity-quality trade-off. So, I hope you enjoyed. So check out the notebook yourself, and if you have any questions, then reach out to me or to Jan, and we will help you.